Good day, everyone, and thank you for joining me. My name is Ashutosh Rana. I'm an enterprise technical architect with a focus on automated integrations and enterprise applications. And currently, I'm working on AI driven systems and AI driven operations at CherryRoad Technologies. Over the last several years, I've been fortunate to work on enterprise automations, integrations, and currently I'm focusing on AI initiatives spanning higher education, healthcare, customer engagement, and enterprise operations. During the journey, one lesson has become remarkably clear: building intelligent agents is no longer the hardest engineering challenge. Modern foundation models are incredibly capable. They can reason, summarize, retrieve information, call tools, and collaborate with other agents. The difficult part is ensuring those capabilities operate safely, transparently, and consistently inside regulated organizations. When executive ask whether AI is ready, they are rarely questioning model intelligence anymore. They know they're pretty capable right now. They are asking whether the system can be trusted. Can we explain why a decision was made? Can we prove the correct policy was applied? Can we demonstrate who approved an action? Can we reconstruct exactly what happened months later during an audit? Those questions are fundamentally about governance, not model quality. So, today's presentation is built around lessons learned from designing enterprise AI systems in production rather than focusing on a particular vendor or a framework. We will examine architectural patterns that remain valuable regardless of the orchestration technology you choose. Whether your organization adopts Google ADK, LangGraph, Crew AI, AutoGen, or any other emerging platforms, these governance principles remains the same. My goal is to give you a practical pattern you can begin implementing immediately and to encourage you to think of governance as a strategic architectural capability, not a compliance exercise anymore. Now, let's start by understanding why governance has become such an important engineering challenge. Most modern frameworks optimize for autonomy. They help agents plan, coordinate work, invoke tools, and communicate efficiently. Those capabilities are valuable, but production environments introduce a very different sets of concern, and three structural gaps appear again and again. The first challenge is authorization. In many implementation, delegated agents simply inherit privileges from the orchestrator. The simple summarization agent may suddenly possess permissions to perform business operations that were never intended for it. That violates least privilege principle and dramatically expand operational risk. The second challenge is hidden policy, routing decisions, escalation thresholds, and business rules become buried inside application logic or prompt templates. As regulations evolve, modifying those embedded rules become expensive and your compliance team cannot audit an if statement they cannot see. The third challenge is fragmented evidence. Different services maintain different logs with different identifiers. During an investigation, teams spend days reconstructing a timeline. What exactly happened? Where exactly things started? Where exactly things ended? What happened in between? Rather than answering the original business question, what did the agent actually do? Notice that these problems are architectural, not model related, which means solving them requires governance patterns, not larger models, and the urgency is real. Enterprise agent deployments grow over 460% year over year, and Gartner names agentic AI governance as a top cybersecurity trend of 2026, precisely because deployment is outpacing governance thanks to the vibe codings and other things that are available to the developers and to the architects and to the IT in search. So let's look at why this matters right now. The business challenge here is simple. The compliance parameter is expanding faster than most architectures can adapt. Multi-agent systems now routinely touch personal data, student records, protected health information, and high-impact decisions. That places them squarely inside overlapping regulatory regimes. GDPR demands lawful basis, data minimization, and a right to explanation for automated decisions affecting EU residents. HIPAA imposes strict access controls and audit obligations wherever agents read, route, or reason over protected health information. FERPA restricts consents and disclosure on student education records, which matters the moment you deploy an academic support agent. And then there is the EU AI Act. Here's the state of the play. as of this month, which is July 2026, as we are speaking right now. The act becomes fully applicable on August 2nd. Next month, the recently agreed AI Omnibus defers most high risk obligations to December 2027 and to August 2028 for product embedded system. But do not misread for the deferrals. The direction is unambiguous. Human oversight, logging, and transparency and obligations are coming, and conformity assessments and EU database registrations are already the expected posture. The trade-off every organization faces is timing. Retrofitting governance under regulatory pressure is always more expensive than building it in. Treat the deferral as a breathing room to build properly, not as a reason to wait. The organization that use this window will lead, the one that don't will bolt. Oversight on at the deadline and get compliance theater. That is exactly what the framework I'm about to show you is designed to prevent. So here's the framework. 5 governance patterns that together form one governance layer, a permanent control plane surrounding every agent interaction on top of any agent framework. Pattern 1, the orchestrator sub-agent privilege boundary, separation of duties for agents. Pattern 2, regulatory context injection, a policy engine that acts before the agent does. Pattern 3, confidence gated delegation, a risk gate on every high impact action. Pattern 4, human overrides, escalation chains, an oversight chain with real authority. Pattern 5, audit complete tool call, logging the evidence layer underneath it all. Individually, each pattern closes one of the gaps we just saw. Together, they compound policy, identity, authorization, oversight, auditability, reinforcing one another. Let's take them one at a time, starting with authorization. Pattern 1, the orchestrator sub-agent privilege boundary. The business challenge. Delegation is where authorization silently breaks. The orchestrator needs broad context to plan, but if everything it delegates inherits that same power, one manipulated or malfunctioning sub-agents can act far beyond its purposes. The pattern. The orchestrator holds the broad reasoning context, but each sub-agent receives only the scoped credentials and tool access its specific task requires. Never the orchestrator's full privilege set. 3 rules make it real. Scoped, short-lived, credential issued per delegated task, not standing service accounts. Tools allow list enforced at the runtime boundary, not by convention, not by prompt engineering, and privilege that never escalates on the way down the delegation chain. You can see it in the diagram. The orchestrator on the top, retrieval action, and notify agents below, each with scoped credentials and no privilege inheritance. The trade-off is engineering effort. Issuing per task credentials take real identity plumbing, but in 2026 that cost is falling fast. NIST launched its AI agent standards initiative in February, framing agents as non-human identities that need dedicated identity, authorization, and accountability controls, not generic service accounts. And MCP version 2 shipping in OR 2.1 authentication makes scoped per task credentials practical at protocol layer itself. What used to be custom engineering is becoming a standard plumbing. The benefit, entire class of incidents become architecturally impossible, but release privilege only tells an agent what it can touch, not what the law says it may do. For what we need pattern 2. Pattern 2, regulatory context injection. The business challenge, compliance logic scattered through code is unauditable and expensive to change. Every regulation update becomes a code change, a release cycle, a risk. The pattern compliance is evaluated at decision time, not bolted on afterwards. Before an agent acts, the applicable regulatory context, jurisdiction, data class, consent state is resolved and injected into agent's runtime context. Walk the flow on the slide. A request arrives. The policy resolver matches data class and jurisdiction to the applicable rules. Those rules attach to the agent's context, and only then does the agent reason and act inside those constraints. The example is the heart of it. An admission agent operating on EU applicant data automatically inherits GDPR data minimization constraint. A healthcare agent automatically inherits HIPAA minimum necessary rules. Same architecture, same agent code, different injected policies. That is the principle I want you to take away. Policy is data, not code. When regulation changes, And as we saw, it changes constantly. You update the policy store, not the agents. Your compliance team can read, review, and version the rules directly. The trade off, you need a policy inventory, and most organizations haven't built one yet. It is genuine work, but the benefit is compliance that is inspectable instead of archaeological, and a system that adopts to next year's rules without a rewrite. Of course, even a perfectly informed agent can still be uncertain. What happens then? That is the pattern 3. Pattern 3, confidence gated delegation. The business challenge, full autonomy is fast but reckless. On high stakes tasks, reviewing everything is safe but kills the economics. You need a principled way to decide per action which mode applies. The pattern, before an agent acts on a high impact task, its confidence is evaluated against a policy threshold. Above the threshold, autonomous execution proceeds, no friction, full speed. Below it, the task routes to more capable agent or a human. You can see the fork on the slide. The critical nuance sits at the bottom. Thresholds vary by task, risk tier. A routine FAQ response and a financial account change are never held to the same bar. The FAQ might clear at 70%, the account change might require 99, or might even always require a human regardless of the score. One important trade-off from the production raw model confidence is poorly calibrated. Don't gate on token probabilities alone. Combine model confidence with business risk, use verifier models or self-consistency checks, and calibrate thresholds in shadow mode against human decisions before you enforce them. The benefit, this is exactly the risk tiered logic the EU AI Act formalizes in law. So you are not aligning your architecture with where the regulation is already going, and when the task does fall below the gate, it has to land somewhere meaningful, which brings us to the human oversight. Pattern 4, human override escalation chains. The business challenge is an uncomfortable truth. A single approve button becomes a rubber stamp with a weak. If oversight is going to be meaningful in the sense of regulator intents, escalation must be tiered, not binary. Each tier defines who is notified, what authority they hold, and how long the system waits before escalating further. Tier 0 is the agent itself, self-resolving within its granted policy and confidence bounds the vast majority of the traffic. Tier 1 is a domain reviewer, a subject matter expert who confirms or corrects unambiguous actions. Tier 2 is an accountable human, a named owner who can approve, override, or halt the workflow entirely, just like a kill switch. Tier 3 is the compliance officer, final authority of a regulatory exception and incident review. And one rule binds the chain. Every escalation and every override decision is written to the audit log with the responsible party's identity and rationale. Oversight that isn't recorded didn't happen, response windows matter. 2. A reviewer who has an hour, not a week, stays engaged. Work that waits too long escalates automatically. The good news, as in the current 2026, the primitives exist. Landgraph shifts, first class human in the loop interrupts with durable checkpointing. Microsoft's agent stack has native approval gates. What you design is the chain itself. Authority, threshold, deadlines. This is where people, process, and technology genuinely reinforce one over the other. And everything this chain produces needs somewhere trustworthy to land. That is the pattern 5. Pattern 5, audit complete tool call logging. The business challenge. When evidence is reconstructed after the fact, it is incomplete, expensive, and suspect. The regulators question, what did the agent actually do? Deserves a better answer than the grab through the 6 services logs, just like what we do in our scripting. The pattern, every tool invocation, inputs, outputs, calling agent, the delegated privileges it held, and the policy context it ran under is written to an immutable, centralized log at the moment it happens. 3 properties make a log audit complete: structured and queryable, not free text. Append only with tamper, evidence. Nobody, human or agent, quietly rewrites history, and correlated by task ID across every agent in the workflow. So you get complete task, lineage, who delegated what, under which policy version and what outcome. Look at the sample log. One support workflow, 4 agents, 4 seconds. 14 or 2, the retrieval agent reads a record. Allowed. A second later, the action agent tries to update billing, escalated. The notify agent sends an email, allowed. The refund transaction denied. One queryable timeline that tells the whole thing, story, including what system refused to do. That refusal record is gold in audit. The trade-off is storage and a little latency. Milliseconds against LLM inference measured in seconds. The benefit is certification grade evidences. ISO 42001 mandates records of AI decision making. And NIST's accountability guidance now explicitly covers capturing agent decisions loops. When the auditor arrives, this log is answer. So, pattern 5, where do today's frameworks leave you? Google's ADK, LangGraph, QAI, AutoGen, each provides strong orchestration primitives. They shape the agent loop very well, but none of them is a complete governance layer. And I say that someone who deploys them in production recently did multiple systems in there, and that challenge is real. The interoperability story has consolidated nicely this year. MCP, the Model Context Protocol, now governed by Linux Foundation with roughly 97 million monthly SDK downloads, has become the standard for agent to tool connectivity. Google's A2A reached version 1.0 for agent to agent coordination. That two-layer architecture, MCP for tools and A2A between agents, is becoming the reference model. But even with protocol maturity, the governance work remains policy before dispatch, tiered human approval, audit evidence. These still have to be engineered on top of whichever stack you choose. And that is deliberate on how this framework is designed. Governance lives as a control plane around the frameworks, not inside any one of them. Each of the 5 patterns layer onto ADK, LangGraph, QAI, AutoGen, or your own custom stack that you have built without a rewrite and without marrying your compliance postures to a vendor roadmap. Let me show you how the patterns map to the regulations themselves. This matrix is a slide your compliance team will want to have a screenshot. Each of the 5 patterns maps to direct enforceable control across GDPR, HIPAA, FERPA, and the EU AI Act. That is what the teal check represents. 2 examples rather than reading the grid. The privilege boundary, pattern 1, directly operationalizes HIPAA's minimum necessary standard and GDPR's data minimization principle. When a record agent physically cannot access more than its task requires, minimum necessity stops being a policy statement and becomes an architectural fact. And audit complete logging, pattern 5 satisfies HIPAA's audit controls and the EU AI Act's record keeping obligations in one stroke because the evidence is generated at the moment of action, not assembled for the auditor. The deeper point, no single pattern satisfies any regulation on its own. Regulators thinks in layered controls, and these 5 patterns compound, each covering the gaps the others leave to satisfy layered multi-jurisdiction obligations. That compounding is the real design goal. Now let me show you these patterns doing real work. 2 case studies first, from higher education and customer engagement. In higher education, we operate an academic advising multi-agent system under FERPA. 3 patterns do the heavy lifting. The retrieval agent reads student records under FERPA scoped credentials, never the orchestrator's full access. So the privilege boundary is structural, not the procedural. The confidence gate routes financial aid, edge cases to human advisor automatically because a mistake there harms a real student's funding. That is business risk overriding raw confidence, exactly as designed. And every record access is logged with student ID, purpose, and requesting agent, which is precisely the disclosure accounting FERPA contemplates. The engineering lessons from this deployment, the hard part wasn't the agents, it was the cataloging which advising task belonged to which risk tier. That policy inventory took longer than the code and was worth more. The second case is a customer support escalation network. Regulatory context injection applies regional consumer protection rules per customer locale. The same agent behaves differently for a customer in Berlin than in Dallas automatically. A tier 1 domain reviewer confirms refunds and account changes above policy thresholds, and the unified audit log correlates every agent touch across a single ticket. So when a customer disputes an outcome, we replay exact what happened, agent by agent, step by step. The same architecture carries into higher stakes domains as well. Healthcare and enterprise operations, where the stakes rise again. In healthcare, under HIPAA, we run a clinical intake assistant network. The orchestrator delegates to a scheduling agent and record agent with disjoint minimum necessary access. The scheduling agent literally cannot read clinical notes, and the records agent cannot touch the calendar. Low confidence triage summarizes escalate to a licensed clinician before anything is written to the chart. A confidence gate backed by a human with genuine clinical authority, which is what the meaningful oversight looks like in the medicine. And every PHI touching tool call generates an immutable log entry that satisfies HIPAA's audit control requirements as a byproduct of normal operations, evidence that exists before anyone asked for it. In enterprise operation, a finance and a procurement workflow shows the same pattern in a different key. The privilege boundary guarantees a document summarization agent can never hold payment execution tools. That entire class of incident is architecturally impossible. The compliance officer tier reviews any escalation involving vendor risk, thresholds, and audit complete logging produces SOC style changes control evidence on demand. Step back and look at the 4 cases together. 4 domains, 4 regulatory regimes, same 5 patterns, different injected policy, and a different tier definition. That is the portability argument demonstrated. Now let's assemble the whole picture. Here's the reference architecture. Follow a request through the diagram with me. A request arrives, and before it reaches any agent, it passes through the policy resolver. Pattern 2, regulatory context resolved and injected upfront. The request, now carrying its constraints, reaches the orchestrator, which delegates to the retrieval, action, and notify agents across the privilege boundary. Pattern 1, each subagent holding only scope task specific credential. At every high impact step, confidence gates decides whether the agent proceeds autonomously. The pattern 3, when confidence falls short or when policy demands it, work routes into the human escalation chain, human in the loop. Pattern 4, with its tiered authority from domain reviewer to compliance officer. And underneath everything, every hop, every delegation, every gate decision, every override, writes to the immutable audit log. Pattern 5, the evidence layer that makes the whole system defensible. Notice that this diagram is a control plane surrounding the agents, not the functionality inside any model. That boxes in the middle could run on ADK, LangGraph, CrewAI, or AutoGen. The governance layer neither knows nor cares. That is what makes it durable as the framework evolves. Let me leave you with the takeaways. The theme of this entire talk: governed by design, not by exception. First, enforce least privilege. Bind every delegation to scope short-lived credentials at runtime boundary, not by convention, but by the runtime. Second, inject policy, don't hardcode it. Resolve jurisdiction and data class into the agent's context before it acts. Policy is data. Your compliance team can read, not code. They have no to excavate. Third, make escalation meaningful. Tiered human oversight with real authority and real deadline at each tier beats a single easily ignorable approval step every time. Fourth, log at the moment of action, immutable correlation audit trails, and dramatically cheaper built in than reconstructed under regulatory pressure. And the larger point behind all 4, enterprise AI success is increasingly measured by trustworthiness, transparency, operational resilience, and regulatory readiness, not benchmark scores. 5 pattern, 1 governance layer, any agent framework, and every piece is buildable today. Not just that, what exactly also matters most, right, is the repeatability of these AI agents. Unless until you can have the same repeatability, which is very important for AI agents today. Before I close, since this is a recorded session, I want to make on the two questions this conference posed to all of us. First, what architectural and governance mechanisms are most effective for ensuring compliance, transparency, and accountability in enterprise scale multi agent AI system? From production experience, the mechanisms that work are the ones enforced at the runtime boundary, not by convention. Three stand out: privilege separation, scoped, short lived, per task credentials with tool allow less. So a subagent can never exceed its mandate even when its reasoning goes wrong. Policy injected as data at decision time. Jurisdiction, data class, and consent state resolved before the agent acts, which makes compliance irrespective inspectable rather than buried in code. And immutable correlated audit logging, one queryable timeline per task across every agent involved. In 2026, these have external validation. NIST's Agent Standard Initiative, ISO 42001's record keeping mandate, or 2.1 in MCP all point in the same direction. And the key insight is compounding. No single control satisfies a regulator. The layered set does. Second, how do we balance autonomous agent decision making with meaningful human oversight while maintaining scalability, efficiency, and compliances? The answer is risk tiered oversight, not uniform oversight. Uniform human review destroys scalability, and worse, it breeds rubber stamping, so oversight becomes theater. Full autonomy destroys accountability, confidence gated delegation, plus tiered escalation gives you both routine, low risk workflows autonomously at machine speed, while human attention concentrates exactly where the risk and uncertainties are highest. Each tier carries defined authority and defined response windows, which is precisely the meaningful oversight required as opposed to a checkbox. The Act's deferral of high risk obligation to late 2027 gives us all a window to build this properly and in a consistent manner. The leaders will use that window, the laggards will board oversight on the deadline and get theater. Thank you for watching. I'm Ashutosh Rana from CherryRoad Technologies. If you would like to discuss any of these 5 patterns or how they map to your own regulatory environment, I would love to connect. Enjoy the rest of the conference.